This question we're asked to find the derivative and then find where the derivative equals 0. Before I can begin, I need to turn the question into a form that uses indices instead of the square roots. And now I'm going to use the product rule. I start by going the first term times the derivative of the second plus the second term times the derivative of the first. I'm going to tidy this up a little bit. The 2 and the minus 2 will cancel out. The minus and the minus will cancel out. So that just leaves us with 4x times 1 minus 2x to the minus a half minus 4 lots of 1 minus 2x to the positive a half. Let's get rid of the indices now. Minus a half means on the bottom of a fraction and it's a square root. So I want to get a common denominator here. So what I really want to do is times this one, top and bottom, by the same piece. So that on my next step I can write them all as a common fraction. I can simplify this top line now. So there we go. We're asked to find out where this derivative equals 0. So to do that, we'll just go back here. Just copy that. So this was our gradient. We want to find where does this equal 0. Well, we've got two parts to a fraction. We've got a numerator and a denominator. Now, if we want this fraction to equal 0, the only option we have is that the numerator equals 0. That's because if the denominator equals 0, we actually have an undefined fraction because we cannot divide by 0. So this question distills then to something a little simpler, where we're really just looking at is when is 12x minus 4 equal to 0. Even though we have a bottom part of the fraction, we don't want to know if that equals 0 unless it happens to be the same value here. So we've got 12x is 4 12ths, which is the same as 1/3. Good practice just to check that at this point this bottom piece doesn't make the gradient function undefined. 1/3 into here will give me 2/3. No, it's not going to be 0, so therefore this is where the gradient equals 0.